Okay, here we go. We are now recording. That is my alarm telling me to do this call, which we are doing. So this is our very last lecture in 436V. It's been quite a wild ride this term between global pandemic and me personally being ill the last few weeks, but I believe that we are in a place where we can go ahead. So let me start with a bunch of announcements. So as I believe many of you have seen, in fact, let me actually go to slide only. There we go. As many of you have seen, of course, there's no Foundations 5 and 6. There's no final exam. Everything is restructured so that for that 24% of the marks, 5% go to the midterm, 10% of the final project, 6% to the programming exercises, and then we're taking off a bit since we don't have that last Foundations exercise. So we're doing this not only because of the COVID situation, but also because based on a bunch of your feedback on the mid-semester evaluation, it really became clear that the workload for some of those exercises was incommensurate with what the old marks were, and that really this is a very project-based course. Almost everything I wanted to test you on, we'd already covered in the midterm. So a much more late-breaking announcement is on milestone 3. After saying that, by God, the due date was Wednesday, April 8th at 11:59 p.m. no matter what, I then heard very recently on Piazza that in fact there were some teams that appeared to be genuinely confused because they'd had milestones reported in M1 and M2 that went all the way to April 10th, and we did not tell them all that that was not the deal. I checked, we told some of those teams that, but it turns out it slipped by us, and other teams we did not reiterate that point. So in order to not penalize those teams in particular, and also again, given the chaotic nature of the world, we decided that I would handle this by saying that you have 2 new grace days so that you can turn that in without a penalty until Friday, 1 minute before midnight. You are very welcome to still turn that in on Wednesday. Also note that on Piazza, we've got the draft rubric released. Here is the rubrics. Here's the rubrics for M1, which we had released a while ago. For M2, which we made sure to get released, I think, a few days ago, maybe yesterday. Excuse me. And then the M3 rubric, note this is a draft rubric. This is not an absolute guarantee, but this is what we're thinking of for the breakdown within the programming achievement, foundations design, and process log write-up sections. As usual, there are some penalties if you don't do a crucial required logistics things, like if you don't actually do the self-assessment, that would be a penalty for you personally, not your whole team. Please do remember that you've got to put on your final version tag. A number of you missed this for M2. And finally, there's also going to be some extra credit possible, up to a total of 5%. For things where people have gone above and beyond, like a really high level of polish, really great explanation in the write-up. If your work actually demonstrates fantastic design and mastery of the concepts of the course, or if you've really gone above and beyond with what you've done technically in terms of the D3 polish. Okay. So also for the M3, those sign-ups are available through the Canvas calendar. So if you are in a big hurry, you could do those as soon as the Saturday. You're certainly not required to do anything on the weekend. And then there's days during slots during the week on the Tuesday and the Wednesday. What I really, 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 really need everyone to do is to be on time for that, because the TAs are under a really tight schedule where we are trying to, because people have explicit sign-up slots, the way it works is they've got 30 minutes per team. Their first 10 minutes will be spent getting everything open, loading that into their head, having a quick look. And then the part where your team actually meets is that 10 minutes in the middle. So either at like, say, 3:10 or 3:40. And the TA will be with your group for up to 10 minutes. We really, really would like all members of the team to join. However, we realize that in chaos times, that might be very difficult for some, especially if you are in another country with a different time zone. That might be extremely difficult. It could be that some of you don't have always available internet connectivity. So at least one group member definitely does need to be able to join. We would really like to have all three, but we realize that might not be possible in all cases. So only one of you should sign up on the Canvas calendar, but all of you should join for the Zoom meeting. Belatedly, this was a slide that I had not actually managed to show before, just briefly to show you the distribution of the marks on the midterm if you were curious. And I believe, if I recall correctly, that the median on that was 79%. Let me just double check that there have not been any questions yet on the chat. Let's see, is the, let's get the chat over here. Come on, mouse, you can do it. Off on my side screen. Okay. And one last reminder on evaluations. These are super important. If you haven't filled that out yet, and I believe that's many, many of you, please do fill that out. I checked, even though I had some virtual class time for that last week after one of the videos, I saw that only 10 out of the 70 of you have actually filled that out so far. So I know it's chaos times, but it would be great if you could find time for that. Note that UBC does not have access to what you wrote in those midterm evaluations. That went only to me personally. So any comments you have about the class, good or bad, are only going to be visible to UBC if you actually fill out their official form. And also the TA evaluations are important. And do please fill out 2 of them, both for Michael and for Zepeng, because for all of you, there really have been interactions with both, given that instead of just having one TA match with one section all through the term, they've been interleaving with all the stuff for us. All right, before I move on to the rules of thumb main material, continuing from last time, let me check if people have questions. If you have any questions, could you either ask them on the group chat or put your hand up in the participant window? Reminder to do that. You open up, go to the bottom, open up participants, and then there's a way to raise your hand if you go down to the more, which has a little hand raise function. Going once, going twice. Okay. Then, oh, I see a raised hand. Great, let me unmute you. Okay, yes, Mohit.
I just wanted to ask if you still have office hours today.
The question is whether I still have office hours today. I hope I will have office hours today. I've been sick enough that my ability to work is somewhat limited. It could be that this will completely wipe me out, but if I can make it, then we will cut over and do what I did before, where I go straight, where I close down the Zoom at the end. I'll let you know how I'm feeling at the very end. But hopefully I'll be able to close down the Zoom, reopen it in the waiting room mode where I can have people then come in one by one or few by few to ask questions in the office hours.
All right, thanks.
Mm-hmm. Any other questions? Going once, going twice. Okay, let's go ahead and get back to the rules of thumb. So, let me do fit slide. There we go. All right. So to remind you, because it's been a few weeks since we talked about all this, we had started by talking about the rules of thumb, and we were right in the middle of the main one, the no unjustified 3D. And so we had talked quite a little bit about a bunch of the drawbacks of unjustified 3D. But then we had just gotten to the fact that, in fact, there are some times when you do have justified 3D, when you actually have truly three-dimensional spatial data, and you really do need to do things like spin around some view to try to understand the three-dimensional structure, because remembering back to the targets when we talked about tasks, when you have intrinsically spatial data and understanding its shape is part of the requirements for understanding things, then that's exactly when you do want to have 3D, both the ability to navigate in 3D to see that structure, and showing that where depth perception is part of understanding that spatial structure. All right, so that's where we ended last time. And now let's talk about a use of justified 3D that's not intrinsically 3D spatial data. It is possible to use 3D even for abstract data in a way that actually is effective and well justified. So I'm not saying never use 3D, but I'm saying be careful to justify it when you do use it. Here's an example that I and many other people regard as a successful use of 3D. So one of these New York Times data journalism examples, in this case it was the economic curve. And let's actually go through and see that. Now in this example, let's make this window a bit bigger. So we start out and we're looking at something that you might normally think of as, at least one view of it, as being a two-dimensional structure. We see this sort of line chart in 2D, but this is actually embedded in a 3D space. And you might say, well, how is this any different than the example, if you remember, last time I showed an example where there were also things in 3D, and I said that this was, oops, here we go. And with this one, I said, well, that's not a good use of 3D. So that's showing a bunch of two-dimensional curves in 3D, and I'd argued this was a poor choice. So what's different here? Well, one thing is, let's go back to the actual example. So here we see a lot has to do with carefully chosen viewpoints. Here we're looking at it from a viewpoint where we can actually understand that we are seeing a three-dimensional structure. Part of what's going on here is the complexity of this data set is such that while there is a little bit of occlusion, there are some places where you can't see behind. There's not a huge amount. It's not the kind of extreme occlusion that we saw in some examples, like, for instance, this one, where there was just a huge amount of three-dimensional structure, and there was quite a lot of intrinsic occlusion, no matter where you looked from. In this example here, we're seeing that there's less occlusion. Start out, this is an example where we can actually move through the different slide versions. So we can see here we're getting some sense. All right, we've got the vertical axis of the yield. We have the length of the time that the forecast is covering, and then we have this year on the x-axis. Now, if we hit the next button, what we see is we see an animated transition. So this is crucial to actually have the continuity. So there is an animated transition. And now we've moved to a sort of head-on, we can think of this like an orthographic projection, a projection directly along one of these axes, and we see something that looks like a two-dimensional view. But we know from context, from what we saw before, that in fact, we've gotten this by moving the camera to a new viewpoint in 3D space. So we're able to analyze parts of this with a 2D structure. This isn't a completely traditional 2D view, like a simple bar chart, but we are seeing basically this line chart with the shading. Again, going to another view now, again, very carefully chosen constrained navigation, not fully just spin this around randomly. And it's focusing our attention on one part of that, what at the time was recent, the year before that, and seeing some of that structure in context where we see that spike. We see that compared to some of the other places, that spike is quite small, but within the local context, the spike is quite large. Now, navigating to another view, it's still, it's almost, but not quite exactly face on to us. So we're still able to see some of that 3D structure, again, from a carefully chosen viewpoint. Now we are in fact looking straight along one of the axes. So that forecast axis is completely gone. We're looking straight down and we see something that looks a lot like basically a line chart with some vertical banding for each of those time points. And then we're able to see this global trend of what the actual rate is, which is what the axis, which is currently vertical to the screen, is showing us. And then the camera's actually moved so it's looking down from above. So we basically see something that's like a heat map because there's that color coding of this, that three-dimensional structure. Looking down shows us the heat map. Then the next one, it's actually showing a different data set for Germany, but from that same point of view. So there's the continuity of the point of view, even though the data has changed. And then we're seeing a similar from the side view for Germany, that like we started out with the US view. And then finally, another data set. Notice how, again, the viewpoint didn't change, the data set changed. So there's always some continuity of either viewpoint or data set. All right, so that was a walk through that curve. And now moving on to the next one. So coming back to sort of summarize this point, I'm not saying never use 3D. I'm saying don't have unjustified 3D. When you have true 3D spatial data, it's almost always legitimate. When you carefully justify and think through what are the properties of your data set, will there be massive occlusion or in fact minimal occlusion? Can you constrain the navigation to have carefully chosen viewpoints instead of just letting them spin things around? You want to very carefully justify it for abstract data. When people started out doing the sort of computer-based visualization in the late 80s and early 90s, there was a huge amount of enthusiasm for this. People did a lot of 3D views. And then as people started actually doing more careful user studies that were rigorous to try to understand, is this helpful or harmful? In fact, in many cases, they found that it was not helpful and often even actively harmful. These days, there's far more skepticism about that than there was 20, 30 years ago. In particular, the very worst cases are three-dimensional point clouds. It can be very hard to actually gauge those depth relationships when things are just, points are hovering in midair. And even putting in some things like a ground plane to help people at least remember which way was up originally, that still is quite a difficult perceptual task. Networks, shown as node-link graphs, is also a very difficult case. So it's really hard to justify 3D for networks. Here you see one of the last 3D network visualizations that made it into a mainstream visualization conference back in 1999, where they're showing the hyperlink structure of the web, where each page is a little block, and then the hyperlinks are shown with these lines through in 3D. This was very hard to actually make sense of in terms of the depth and the occlusion relationships. Not to mention a rather creative color scheme that might not be super well chosen in terms of distinguishability with that background plane as a pink. Okay, any questions on the 3D material? Going once. Harlan, can we use things like VR to see 3D visualizations better? Good question. That is actually coming up, I believe, on a next slide. Let me actually just jump forward to that slide, which is actually about VR. So my slogan for this one, a lot of the rules of thumb are in slogan form, just so you have some hope of remembering them, is that resolution beats immersion. And so what do I mean by that? One of the key things about VR, virtual reality, or AR, augmented reality, sometimes called MR, mixed reality, is that you actually have the sense of immersion. That because with many of these, you are either using, say, some sort of head-mounted display where when you move your head, everything moves with you. So that feels very natural as opposed to a fixed image plane like we have with laptops or desktops. So that sense of immersion can be really important for some things. For if you are doing, say, a walkthrough of a house and you want people to have a rendered architectural building before it's built and you want to get a sense of what it would feel like to actually inhabit that space, immersion can be really, really helpful. So that sense of presence, how often do you actually need that for abstract data sets? The answer is not very often. So what is true is that one of the ways to understand 3D depths is to have stereoscopic 3D, where you actually have a different image going to each eye, and then your eyes fuse those to get that structure. A lot of people think of stereo as the main way that they get depth, but in fact, it's one of the more secondary cues. One of the main cues for understanding depth is actually the fact that when you move your head, the occlusion relationships between more distant things change. It's called head motion parallax. That's actually a stronger cue. But there is definitely some ability to disambiguate depth with stereo. So the question is, when does the benefit of the sense of presence in the stereoscopic 3D actually offset some of the costs? So let's think about what the costs are. Well, for one thing, if a lot of the time that you're using visualization, your goal is not to simply visualize for a long period of time. You are often integrating where you're looking at a visualization and then you're using other computational tools. Maybe you have to look something up on your email or browse something on the web or use a data analysis system that involves typing. There's a number of things you're often doing interleaved with visualization, and that's going to be much, 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 much easier on some sort of desktop non-immersive system. The other thing I really want people to think about is we've talked a lot in this class about information density and how important it is to use pixels wisely. So pixels are basically your scarcest resource in visualization. Pixels are often even more of a scarce resource than something like the user attention. These days, you still are typically paying a cost with resolution. It's typically the case that in order to have an immersive VR or AR display, you're seeing a much smaller number of pixels than would be possible on a desktop. It's actually quite common these days that on the desktop, people can have high-res displays, maybe 4K pixels in one direction, even multiple displays. So to try to compare that amount of pixels with what you might see on a head mount, where you're seeing often a much smaller number of pixels. They might be spread more through your field of view by optics. Those optics often serve to blur things like text, making that harder to read. So although some of the technology has improved dramatically in the last, say, 5-10 years compared to 20 or 30 years ago, the rendering is much faster, the lag is then much less. The 3D position sensing is much better than in the old days. You still are paying this price of non-integration with the desktop and resolution. So far, VR for abstract data has not been well justified. These are a few older shots where people are doing unwise things like 3D pie charts suspended in these VR rooms. These are even black and white because it was quite some time ago that people were enthusiastic about this. However, and I know this is a long answer to the question, but the one thing that has changed lately with the new technology is augmented reality, where you actually, instead of having a fully virtual environment, you're seeing what's around you, maybe through some sort of camera system or some sort of transparent see-through glass system. And then you are able to embed visualizations within the context of your surroundings. There may well be some interesting opportunities for that. There was quite a good talk. I had you guys watch the Georgia Lupe capstone from the IEEE Viz conference. Just the year after that, Dieter Schlumstad gave a great talk about the convergence of visualization and augmented reality that was quite compelling in terms of painting a vision for some of that utility. So, long answer, is that clear now? Great, okay. Any other questions on 3D or VR or AR? All right, let's go back to where we were, which was let me now mention, it's not just about unjustified 2D. No, 3D, it's like no unjustified 2D is also a consideration. So, and this is mainly to get you to think carefully about when should you actually show a network? So does your network data rely on a two-dimensional spatial layout? In some cases, you might have data that maybe was originally gathered in the form of a network or that you could easily transform into a network. And the question is, do you need to understand that network topology to do the task? In cases where you actually need to read a lot of things that might be considered text labels on the nodes in the graph, you have to think about whether the information density cost is worth it. If you arrange it as a network so that you've got the nodes spread out in space, you're typically not going to be able to have as dense of an ability to draw text as it would be if you simply had it in, say, some sort of linear form, like just a list where you have more ability to show the text because you don't have the space in between to position the labels. So you always want to think about, is it worth it? Is it important given your task? One place where there used to be a great deal of enthusiasm for network layouts that over time has really died down because some of those costs have become more apparent, for example, is visualization of search results. In the early to mid 90s, there was a huge amount of visualization of search results. That's how a lot of people got into visualization. I was one of them, where our idea was, wow, it's difficult to search the web. Let's show you the hyperlink structure of the web as a key part of helping you get oriented. It turned out that at the end of the day, people did not need to understand the hyperlink structure of the web in order to assess whether their search result was high quality or not. As search engine algorithms got better, basically with the advent, well, as search engines happened at all. Remember in the early 90s, there was no search. The first search result of Vista, Google came around much later in the late 90s. As the algorithms for search got better, the need to visualize the results really plummeted and it became much less popular. Also be very careful with document collections, where typically to understand what a document, the meaning of a node that is a document is, you might have to read quite a lot of text. Or ontologies, when do you really need to understand the structure of things like ontologies on the semantic web? Often you don't care about their topological structure, you just might need to read the category names and have a much simpler visualization of that. All right, another principle is eyes beat memory. Now we've seen some examples of this so far in the term, but it's worth talking about it a little more explicitly. So in this class, we're thinking a lot about when can we use external cognition, that is, have your eyes look at a specifically designed display that's off of the screen, and use the perceptual system instead of using internal cognitive and memory resources. So you always want to think, when am I showing something directly versus making them rely on memory? So the principle we talked about when we talked about juxtaposed views is that it's easier to compare by moving your eyes between views that are side by side compared to thinking about a single interactive view where you only see the current state and you have to remember what you saw before. And so you're comparing what's visible now to memory versus comparing two things that are visible at the same time when you can very, very quickly just move your eyes between. So that principle is one that's worth thinking about very explicitly. It has strong implications for animation. So it's worth thinking about animation. Many people start out with the intuition, just like a lot of people start out with the intuition that if 2D is good, 3D must be better. There's also this intuition that animation must be great for storytelling. After all, you see animations in the form of, say, Disney movies, Pixar movies, where there's this amazing choreographed storytelling with animation. But there's a key thing there. The reason those are so great for animation, that the animation is used so effectively, is that a human specifically made decisions about what's going on the screen. It is choreographed. Somebody actually thought through the actions of everything happening on the screen, and there's a basic rule in animation, which is really that only one thing at a time should be happening. Everything is carefully designed to draw your eye to the spot on the screen that's crucial to the action at that moment. There's a great SIGGRAPH paper by John Lasseter about applying the principles of traditional animation to computer-based animation back from the early 80s. So that kind of choreography is not necessarily the case in a data-driven visualization. So animation is great when you're transitioning between two states and there's some way that you can have the items move in a coherent fashion from one state to the other. But it really doesn't work very well when there's many, many states where changes are happening all over the screen and there's many states. And that's exactly the situation where you really want to consider small multiples. So the part that I want to emphasize is if there is change over time, a lot of people have this intuition that you should so change over time by having views that change over time with animation, as opposed to this much more abstract way of thinking, which is that you could even show changes over time by spatially arranging things in terms of small multiples. One is very literal, one is actually much more of an abstract choice. So small multiples might be a situation where you really have interactive multiple views. That's where we first heard about that in this class when we were talking about linked views with highlighting across them. But you might also simply show small multiples as a way of actually showing change over time in a way that doesn't require this memory the way you need for traditional animations. So specifically go back to this example that we did briefly see before, where we do have an attribute that's changing over time, which is the quantitative value that's used to color these nodes in a graph, showing how much genes are turned on or turned off. And by simply moving your eyes between those views, you can really more easily see, again, this example that things are roughly the same. This is an experimental intervention on the top versus the standard one on the bottom. And it's time 1 hour 1, 2, 4, and 24 hours after the intervention. So they pretty much align at that first hour and even that second hour, but there's really a disparity between the amount of red and the amount of green on these views in hour 4, showing that something really did happen as a result of the intervention, and then they both are roughly back to the same baseline after 24 hours. We are able to see that by moving our eyes. And this is the one time when I actually do need to play this as an animation. Whereas with this view where things are just jumping around, it's really hard to actually follow even just those 8 views. So when there is a lot happening in disparate regions, that's exactly when animation is most difficult. So if you're just flipping back and forth between 2, it works well. If there's only a small region where major change is happening, or a whole group of things can move coherently, then it can work. But this is a very different case than that safe space of animated transitions. We just saw animated transitions in the example before of the 3D graph. All right. Another example of this, which I want to come back to, we actually saw this early on in the term. this idea of change blindness, that if you aren't attending for the exact spot where the change is happening, even a drastic change might not be noticeable. And do you remember the experiment we talked about where a passerby was giving directions to someone, and then experimenters actually went between those two people with a door, just blundering through? This should not happen today in these days of physical and social distancing. And people didn't notice when the person they were talking to actually changed. One snuck away behind the door and the other came into the scene. So if people don't notice something like that, think about the difficulties in noticing change in a view like this by comparison. So I want to go back to this idea of change blindness. We just saw that one example before, but let's actually look at a few more examples of this change blindness. So remember that the way this actually works, if you just flip between two things, you can actually really notice changes, but if it's masked by having a blank screen in between, it is much harder to see. So here we see some flipping back and forth, and it's not easy to see that change. In fact, even though I've seen this before, I couldn't notice it here. So if we look at that man on the far left, let's see. Aha. They're actually flipping color. This is a really large and very salient change from the point of view of just pixels in the scene. So remember, if you can't even notice that, how are you going to notice complex data-driven animation changes? What about this one? Street scene. If you're looking at the center, what is going on? We're not showing for a whole minute. The person who made this video has done that. I won't make you sit through a minute of it. Again, once we focus attention on a specific spot, then car window on the right. Let's see. Notice how there's a really shiny specular highlight on one, but not in the other. One more. US money. Again, I've actually even, yes, seen these before. If you pay attention to this background, notice how in one case it's much darker, in one case it's much lighter. So think about this. If you were actually, let me go ahead and have this play. Right in the center of field of view, you were looking at that. And the key thing is, going back to this example here, where this was a very salient change in luminance of a lot of pixels, and yet we still didn't notice, and it was only one region. It was because we didn't know where to attend to. So this is the perceptual reasons underlying why it can be so very hard to track animation. So both 3D and animation are places where people have intuitions that don't necessarily match the reality in these data-driven settings, where you can't control, if you have something that's fully data-driven, how much change there's going to be in a view. All right, any questions on change blindness? Okay, we already talked about VR and AR. Here's another common mantra. In fact, I did not make up this mantra. This actually came from Ben Schneiderman. Overview first, zoom and filter, details on demand. And this is a sort of easy to remember way of thinking about when you are starting with a visualization, starting, if at all possible, with an overview that serves as a summary of the entire data set is incredibly powerful. And seeing that summary first and having that summary be informative about what might be interesting areas to inspect in more detail, for example, by zooming in to see more and then filtering out the extraneous parts, whether that's with just pure navigation or with things like filtering. That, how do you know where to look if you didn't see some kind of overview at the beginning? And then being able to see details for some very small number of chosen items. So this actually fits into the structure of the query higher level task that I talked about quite a while ago. You know, details on demand is about identifying a single thing to see. Zoom and filtering allows you to compare a smaller number of things, and that's summarizing the whole entire data set. That's about getting this overview. Now, what's the hard part here? The hard part is that designing an effective overview is basically a summary. Designing that overview is a microcosm of the entire question of how to design a visualization. It can be extraordinarily difficult to create an effective overview, especially if you have a complex data set where it's not just trivial to simply plot every single point in a way that works. A lot of what we talked about in the whole second half of the foundations lectures of the class is how do we handle complexity? Where typically an overview is not something that we're handling purely through interaction of a changing view. An overview is somehow showing a summary all in one single screen. Typically, if an overview that extends beyond a single screen is much, much harder to actually use effectively. So as when you're thinking about the design of your final projects, there's a huge difference between everything visible on one screen together that you don't have to scroll to see versus something where you have to scroll. Why is that? As soon as you have to scroll to see more things, we're back in the setting we just talked about eyes over memory. Now you have to remember what you saw before. They're not visible side by side. So the importance of having a summary view where you can see everything at once, as your data set gets more and more complex, you have to typically do some sort of aggregation or thoughtful summarization to actually see the full data set. So this mantra has been very influential. A lot of people use this as a way to guide design. For a first cut, I do strongly recommend that you think this way. There may well be data sets that are sufficiently complex that it is impossible to have a meaningful overview. Once you start thinking about things like, graph networks with millions of nodes, right, or huge, enormous data sets with great complexity, maybe you can't actually show an overview first. Maybe you have to start with some sort of a query and then explore local neighborhoods around that. But you should always think, if I'm going to ask the user to filter, how do they know what to filter for? So it's typically much less effective to simply start by having, say, a bunch of, maybe you have a interface that allows you to have a view where you can pick, say, a scatter plot and what's on which axis. And maybe you have 9 variables and you can say, well, I can pick which 2 of them to see at once on this scatter plot. Some of you proposed things like this in your sketches in some of the design problems we had. But then you always have to think, how does the user know which things to assign to which axis? If you didn't provide an overview, it's difficult for them to know. If they have to go through and systematically check all combinations one by one, you're back in that eyes versus memory situation where they have to remember what they saw before. So overviews are a very, very important and difficult thing, and I strongly encourage you to think carefully about them. Any questions on this one? Okay, now here's another one of these slogans: function first, form next. Some of you might have heard of slogans like form over function, which is an idea that comes out of the art and design world. The advice I give to you on this one is, in fact, not form over function, but function first and form next. And what I mean by that is that I strongly encourage you for visualizations to start with a focus on functionality. The reason for that is that it is possible to come up with something functional and then improve the aesthetics by refining them. That is a possible path towards improvement. In this class, we basically have given almost zero time to discussing issues of graphic design and visual design. We've talked about visualization design, but not about graphic design. If you, say, are graduated and working on a visualization project in industry, and you don't personally have any expertise in this, it's often possible to find strong graphic designers who are able to work with you to do this kind of improvement. So what I will say here is that aesthetics, even though we have not been talking about them much so far, they really do matter. You can even think of them as another level of function, which has to do with how people actually can interpret data visually. There's things like a visual hierarchy. Where do your eyes actually move within the screen? The alignment of elements in the screen, how your eyes flow between them. One thing that we did not have time to cover in this class are what's called the Gestalt Principles that have to do with a lot of low-level perceptual questions of how do you actually interpret things like what's the foreground and what's the background, figure ground, assumptions people make about whether shapes actually continue if there's something occluding. So these things do matter, they're important. We did not have time to cover them much in class. Why not the other way around? Why don't we start with the aesthetics and then get those beautiful and then worry about function? And the answer is that for visualization, that's dangerous because it's usually almost impossible to retroactively add functionality. If you have something that's pretty but useless, you just hit a wall. You really have to start over from scratch. Whereas if you have something that's useful but really visually clunky, you can refine that. That's why I recommend function first and form next. So let's very, very, very briefly just talk about a few basic principles of graphic design. Here's some great examples from the Non-Designer's Design book by Robin Williams. She actually walks through, and she does not focus on visualization specifically, but just talks about some basic principles. Here's an example of the kind of book cover somebody might think about doing the first time they get at a word processor. I've got a bunch of centered text. And she points out, well, one, this is not the Robin Williams that you might know from, that was a comedian. This is a graphic designer. So proximity is one of the things that matters. We've talked a huge amount about proximity in this class, right? About the idea that spatial proximity implies grouping. So that's actually something you can also think about in terms of the overall layout of any individual screen. That if things are related, you want to group them together. And notice how in this first example, there's basically a sort of equal white space between things. But if what you want to do is show what things are grouped together, then you can use different amounts of white space between things as a way to visually indicate grouping. This is a fundamental principle of graphic design. Another is alignment. Having things that actually line up is easier to read because you interpret that. It's easier to actually have your eyes flow from one to the other. So here's an example where things are, in this case, they're right aligned. They could also be, say, left aligned, as opposed to always centering everything. There are contexts where centering makes sense, but there's a lot where you actually want to form a strong line. Another example is to actually have repetition of, in some cases, you can have little elements, like in this case with the small triangles. And finally, the last idea is contrast, that having things that are almost but not quite identical is really, really distracting. Typically, what you want to do is have things that are either very different or completely consistent, but you don't usually want small inconsistencies. I really encourage you to think about this as you're putting a final level of polish on your projects, where you want to, if you have something, be consistent. Clearly, we care about consistency with color, just given the visualization principles of using color to encode. But in general, think about if you've got different titles and legends in places, make sure that things of the same sort of level of importance are the same font. Don't have one thing that's 8-point font and one thing that's 9-point font, for example, for the labels in something. You know, have a larger font for your title of your entire thing than maybe your axis labels, but think about consistency whenever possible. So these are just some really basic graphic design principles. If you are at all interested in this kind of thing, I strongly recommend the book that she did, the Non-Designer's Design book. It's very, very, very practical and easy reading and fast reading, and you can literally buy it and just work through it cover to cover. It's a really good place to start for some basic graphic design if that's something that you do not have any training in, which may well be true for many of you. It certainly is not something that comes up in a typical computer science curriculum. So speaking of labeling, let's really talk about the best practices for labeling. One problem that a lot of you ran into in M2 was that you hadn't made as much progress as we had hoped on the making the visualization as self-documenting as possible. So I do want to emphasize that this is a quite important consideration for the final version of your project. We do have that as a requirement that your visualization should be self-documenting. If you just have a window that has a couple of charts in it with no other explanation at all, how do we even know what these mean? Remember that we actually encouraged you in the feedback for M2 generally, have someone who's not one of the team members just literally look at your visualization and just don't say anything. Just have them look at it where your lips are sealed and see if it makes sense to them. And if they start asking questions, think of that as opportunities to add some useful textual information and labels. So definitely you need a title. Also make sure that your project, and your title shouldn't just be your team name, which at this point is often quite different from your actual project. You should have a meaningful title for your main window. In fact, for any other windows as well. So it should be meaningful, it should be useful, it shouldn't be 436V final project. It should actually be the title of the visualization itself. You always want to think about having labels and legends as much as possible so that it is self-explanatory. You definitely want labels for any kind of axes, for any kind of sub-windows or panes. You often want a label for that. Make sure that your axes actually have well-chosen tick mark placement. You often want to show the min and the max. Essentially, everything that's plotted really should have a legend, particularly for showing things like color coding or shape coding. That's going to be critical. The legend doesn't necessarily need to have the same title as the main thing, if that's redundant. Some of you asked on Piazza, should the legend describe interaction? That's not so typically done. Often the legend is for the more static aspects of the visual encoding. I see a picture. Do I mean it should be in a little blurb as if it were an article or something? You don't necessarily need to have full-on text blurbs. Some of you are actually doing scrolly telling style articles, like you might see in a data journalism context. If that's what you're doing, then you need a lot of text. Most of you, however, are doing more text minimal projects, but text minimal doesn't mean text zero. If there is room on the main screen for some kind of explanatory text beyond just sort of basic titles and labels, you could consider adding some. One of the principles you might want to think about is very few people, if there's a help screen that explains it all in detail, that's better than not having a help screen, but a lot of people won't click on that. What crucial information from that could you just integrate from the main view? On the other hand, as we just talked about earlier today, pixels are a very precious resource. You're going to want to spend a lot of them on the main visualizations themselves. So it's a judgment call. A judgment call of what you can actually put with text on the visualization for explanatory context. I mean, you do, after all, have a whole write-up for explaining things like your design decisions, but imagine that someone were actually trying to use this visualization. You may well need to have some explanation of, well, what's it for? What's it doing? How does it work? What do all these things on the screen mean? So you can decide, is there a little bit of text in the main window? Is there a separate help view? Do you just scroll down from a main window to actually see some more explanatory text as a second level of information? So the answer will not be the same for all people. It'll be different for each team, but I want you to really think about having it be self-documenting. Does that answer your question? Great. Also, just to make sure, with some libraries that you use, there's often scientific notation as a default that doesn't necessarily make a whole lot of sense for many of the visualizations you'll use. So really think about what the numerical format should be for things like your axes. Should you have, full numbers like 17,768, 17,768? Should you just abbreviate that to 17K? It's probably not the right answer to have 1.7e to the, I forget what, 4, 5. So think about what the right format is. Just because all visualization is better with XKCD, let me point out why you should always label your axes at the bottom. So you can all do better. You can all label your axes. All right, so we've talked through a bunch of rules of thumb. To remind you, for the no unjustified 3D, we had talked about the power of the two-dimensional plane, because planar spatial position is much more accurately sensed than depth into the scene, where there's a real disparity between judging depth in 3D versus vertical or horizontal positions in the 2D plane. Occlusion can hide information. There's really a lot of dangers in having the perspective distortion of things getting smaller as they go off into the distance. That makes a lot of the perceptual comparisons essentially either difficult or impossible. And of course, tilted text is really hard to read with current technology. Today, we talked more about unjustified 2D, this principle of eyes beating memory, of resolution over immersion, this mantra, overview first, zoom and filter, details on demand. And then just now we talked a bit about this question of function and form. Okay, any questions on the rules of thumb? Going once. Going twice. Okay. Further reading on this, if people are interested, both from my own book and this Non-Designer's Design book. So now let's talk a little bit about next steps. So I chose the videos last week, not only because I was too sick to actually lecture, but as a way to sort of open your eyes up to a few different things. One is there's a lot of really great stuff out there. If you want to continue learning about visualization, a pretty low effort way is to watch a bunch of these free videos online. The big three conferences that have quite accessible talks are OpenVis, IO, and Information Plus. And in the talk slides, there are links to all of these. So those talks are typically quite polished, designed for a fairly broad audience, are often trying to, the OpenVisConf will be a bit more technical. The open part means open source visualization, so they don't talk at all about any proprietary tools. It's very focused, so D3, unsurprisingly, is certainly one of the tooling systems that's really featured in a lot of those talks, also some things like R and Python. IO is targeted at sort of a mix of, it's not only about visualization, but it does include a lot of broad spectrum visualization, a mix of artists and scientists. And Information Plus is specifically trying to bring together people from the hard sciences with the social sciences and digital humanities, and artists and designers, and it really is trying to have a mix of bridging between the more computer science flavored folks and some of the people from other disciplines. If what you're looking for is research that's cutting edge, then certainly the IEEE Viz conference is the place to look for that. Of course, one of the main things that comes out of that is research papers, which is a place to read more about techniques, but also all those talks for the last several years have been recorded on videos. The videos are not incredibly well organized on Vimeo, sadly enough, but those videos do exist and they are good resources. So what I really wanted to get you thinking about last week was to think about this really broad universe beyond just making basic charts. If all you were ever going to do was make basic charts, actually, there's some other tools that are perhaps more suited for that. I'm going to get to that in just a few slides. Our choice to emphasize D3 in this class is to give you some knowledge about a technical ecosystem that lets you move beyond pre-generated chart types. It really is the key tool for innovating, for coming up with things that are not just cookie cutter charts. So the foundations aspect of the class is to teach you enough theory to actually find your way through this vast number of choices you make once you just go beyond basic chart types. So the foundations gives you the theory to find a path, and D3 is the premier tool for having the ability to do more sophisticated things beyond just here's a bar chart, here's a line chart. So I was really encouraging people to think about that with the videos from last week. So what is the world beyond D3? And this is just going to briefly talk through some of the ecosystems really beyond D3. So again, the reason we picked D3 is that this really is the state of the art in browser-based visualization that is interactive. It, as you've noticed, it has a very substantial learning curve, but its great benefit is that you don't suddenly hit a wall. With basically every other tool I'm about to tell you about, if people want to do sufficiently complex things, they hit that wall and they have to move from that tooling environment to D3. So you've started already on the path that doesn't have a wall along the way. So you've probably, a lot of you have already seen the Observable Gallery, which has got, well over 100 well categorized and carefully curated D3 blocks and code. Of course, there's also the blocks that many of you have seen. In addition, if you're looking for more D3 resources, Christophe Viau's big list of D3 objects is definitely something to be aware of because it's got almost 2,500 examples as opposed to a few hundred. So, we could keep scrolling on. This is the visual index. Notice how you are also able to search. And there's the static list form if you're looking for something like where you might know the words and you wonder if an example of a D3 block exists. So be also aware of this long list of somewhat curated D3 blocks. All right, so that's D3. That's what you've already been playing with for the last several months. What are some of the other options? Well, it's worth mentioning there's one quite interesting layer called Vega Light, which is built on top of D3. It's actually built by the same group, Jeff Hare's group at UW, that was involved in originally designing D3. So this is a layer on top of D3 that's trying to be more concise, where it's a descriptive syntax for doing some of the same things you can do in D3. And there's also some clever things for providing some amount of interaction about that. So if you're curious about this layer on top of D3, Vega Light is an interesting possibility. So another really major contender for programming environments for visualization is R. So this is a scripting-oriented environment. It's used a lot for data analysis, very, very heavily used in science, as opposed to, say, business. It is particularly well suited for quite carefully curated static graphics. It is possible to do some interaction in R using the Shiny framework. But that is something where you can do some interaction, but often you might hit the point of, if you want to do something truly complex, you would need to cut over to D3. There's a lot of integration between R and JavaScript exactly for this reason. The main tool sets are the so-called tidyverse, which is a whole suite of R packages that all work together, and the sort of workhorse for visualization in R is ggplot2. And I'll note that it's got quite an active community of people with a huge amount of tutorials and welcoming, and the RStudio startup is a key part of that. Someone who used to be here at UBC Stats, Jenny Bryan, is a core part of that, as is Hadley Wickham, who designed a lot of these core packages like ggplot and the tidyverse. So this is particularly crucial if you're going to be doing a lot of data analysis. R is very, very well suited for interplay between visualization and data analysis, more so than JavaScript, where you might have to roll a lot of your own analysis code. Another option is Python. There's definitely a fair amount of visualization activity in Python. The workhorse is matplotlib. Powerful, but perhaps not incredibly visually beautiful. Seaborn is typically a more graphically powerful and flexible approach, although it's not as popular as matplotlib. Altair, another one built on top of that. If people are curious about that, still my favorite resource for deciding which of the many Python charting libraries you might want to use is this lovely blog post in the form of a dramatic tour through the Python data visualization landscape. It's basically told in terms of a dinner party between a bunch of different tools, including matplotlib and Seaborn, in the form of them actually being characters and showing how you would do different plots and trash talking all the other ones in terms of what they're good for and what they're bad for. So if you like humor in your visualization tutorials, this is for you. All right, another programming style environment was an older system called processing that was originally designed for artists, but in fact does have quite a lot of visualization capabilities and has a really rich set of tutorials and onboarding tools. And it's really had new life in the last several years by having a JavaScript version. So P5.js is the JavaScript version of processing, and it's got, again, quite a vibrant user community. Now, it's not just programming. There are some applications that people use heavily for visualization. The major contender is Tableau. It is a GUI application. You do a lot of dragging and dropping. A lot of the theory of marks and channels that we've talked about in this class is directly incorporated in its fundamental design. So you can, with dragging and dropping, assign different, basically, data fields to be marks, to have different visual channels of how they're encoded. It does a lot of automatic aggregation, in fact, aggressive aggregation that you have to sometimes back off from if you're looking at smaller data sets. If you're interested in playing around with that, you can do that for free while you're still a student. You can get a free one-year license. It's extremely powerful, although there are some things it just simply cannot do. It's not particularly well suited for network data at all. Certain kinds of interactions are easy, other kinds of interactions are just difficult, and many are simply impossible. So it's not going to give you the flexibility of D3, but it could be good, for, especially for rapid prototyping as you're playing with a data set initially, although it does have a non-trivial learning curve. So that's something to keep in mind. So it's not an instant pickup thing, but it could be an interesting thing to add to your toolkit. It's particularly used in business intelligence environments like finance and some other industrial settings. Another contender that I don't have listed here, but just for the record, is Power BI from Microsoft, which is also another sort of quite complex GUI application. I would be lying if I didn't tell you that Excel, in fact, is the most widely used visualization environment in the entire world. Most visualization people are not thrilled by this fact, but it is the reality. It is the most widely used visualization environment. People do a huge amount of charting in Excel. Sadly, many of its defaults are, from a visualization point of view, somewhere between insane and moronic. A lot of these things we've been telling you to be careful about, Excel just pushes you towards doing. Gratuitous 3D, crazy uses of non-consistent colors, quite a limited palette of charts. So not your perfect choice, but it is certainly out there. And then finally, it's worth noting that there are a lot of charting libraries, and particularly if you find yourself doing some visualization in jobs or in projects after this class, you might be interested in exploring some of those if all you need to do is quickly create one chart. There's a suite of 2 great articles by Lisa Charlotte Roast where she really talks through what these different charting libraries are good for. A few years ago, back in 2016, she did the first version of this, where she literally made the same chart using a whole bunch of different tools. Here's some great animated GIFs actually showing you the process of creation and their outcomes. And so a bunch of the tools we've talked about, plus many, many other libraries and tools, are things she talks about here. And she has some nice positioning of, in terms of flexibility, static versus interactive, ease of learning versus flexibility. And so she really distinguishes some of the charting libraries from things like applications or full-on programming environments like D3 or R. Of course, the world changes quickly. She did a follow-up to that, revisiting some of these several years later. I think this was from, 2018. And she actually then went to work for one of the major charting libraries, which is Data Wrapper, particularly heavily used by journalists. And so those of you who are interested in quickly creating charts, they've actually got one of the most thoughtful set of COVID visualizations that's out there that they've been updating daily. Another somewhat heavily used set of tools is the HiCharts package. I've also got some pointers to that. What I'll point out with Data Wrapper is there is a really, really great set of blog posts by the same person, Lisa Charlotte Roast, who did those charting articles. There are a number of blog posts that are not necessarily specific to Data Wrapper, but that talk about a bunch of visualization design principles. So this weekly chart column is quite well done for that. So that's a great resource if people are interested in learning more after this class. Another really great resource in terms of blogs, Andy Kirk's Visualizing Data site has a very thoughtful set of blogs. A lot of the examples that I used in the Socrative quizzes and in fact in some of the lecture slides were where I simply went through his monthly digest of the best of data visualization to try to find some compelling and modern examples. So if you're interested in learning more or just want to browse some great stuff, his blog is a super useful resource. He also creates lists for the entire year in addition to these monthly ones. And also for tools, the resources page, which lets you actually filter by whether it's a programming-oriented environment or an application, whether it's for geographic maps or focusing on color in particular. So he does keep this guide updated. This is the best guide that I know of the quickly changing terrain of tools. There are a lot of resources here. We can see if we actually go to this live page and start scrolling down that, at the moment it's just arranged A through Z, but there are a lot of packages that he actually has as an index ranging from things like Google Sheets to specific sophisticated color pickers to packages like jQuery. So there's a lot that's here that's kept fairly up to date. All right, let me just mention a few more resources in terms of things you could also think about. One of the things we focused on a lot in this class is this idea of redesign, of you take a design and you think, how could I make that better? How can I critique it? How can I redesign it? If this is something that you're interested in pursuing, then a really great resource is Makeover Mondays. It's an easy entry point because every week they post a data set and they encourage people to make a bunch of redesigns of an original. It is focused on the Tableau tool, but you don't have to just use Tableau to participate. And what's nice about it, also, if you just want to sort of push your thinking, even if you don't participate yourself in actually doing these makeover challenges, just looking at what people do. For example, here's one. I'll pick one at random. Annual sunshine hours. Surely we care about this in Vancouver. So They often have, what they do is they often call out specific favorites and then talk through them. Like here is one, let's see, which is, and it's what's quite active on Twitter is that people post these and then, so let's see, so they start out with an original visualization and then challenge people to make redesign alternatives. There's typically a fair amount of activity on Twitter. They give you the data set, walk through some of them, but a lot of the interesting action is looking at the very large set of things that people might post on in a given week. So that's a nice resource for what I'll call low effort redesign. There is what you heard about in last week's talk was the fabulous Dear Data project, where they really are going through and they have these 52 weeks where they gather data. They absolutely are not constrained by given chart types. So if you go through and you look at these 52 weeks where they gathered the data, they each came up with their own visualizations of it. They drew it on a postcard and literally sent it to each other through the mail. Let's look at the books one. And what's nice about this is, going back up to the top here, they show you both the visualizations and talk a bit about their process for that with some amount of screenshots. The very process-oriented one, which you also heard about in one of the talks last time, was this data sketches. This is much more focused on really, really in-depth discussion of techniques and tools, and particularly there's a lot of D3 discussion in the data sketches project. The original idea was that they would do one of these a month as opposed to one a week, so they had more time. Then it went on, and it actually took them a few years to completely finish up. But these are very, very in-depth. Let's actually, let me grab this one to look at. And as they talked about a bit in the video, they really give very, very detailed process logs. They first talk about data gathering and data pre-processing. They walk through a bunch of their sketches. And then they really talk in depth, and this is what's pretty unique about this project, about the code, and they talk you through some of the major issues in implementation about how they coded it. They show a whole bunch of intermediate result pictures, which is really fantastic for understanding a design process. And then they always have a link to the final version. Some of these were quite high-profile ones. Including things like the interactive visualization of every song in Hamilton. All right, so what else can you do that's local? If you're interested in things around here, so specifically at UBC, I actually run an initiative called Viz at UBC. If you're interested in hearing about things like talks, maybe if you're going to be on campus over the next year, if you're not instantly graduating, you could get on that email list to hear about talk announcements. In Vancouver specifically, probably the best resource is the data visualization meetup. Got about 4,000 members. They, well, in times that are not in lockdown, they do regular talks. And of course, it's free to join. And then you'll hear about events that are happening in the city. And then there's this cool resource that's global that actually just got founded a little over a year ago, the Data Visualization Society. It's got over 10,000 members all over the place. It's become the really great collection of resources. It's the place to look for jobs in terms of particularly short-term contract jobs, but also longer-term jobs focused on visualization. So it now hosts that jobs board. Very incredibly active Slack with a huge amount of interest groups, including local regions and so on, of people talking to each other about topics in visualization. It regularly does visualization challenges with specific data sets. And a lot of that energy has been funneled into a whole series of Medium articles. They've got this journal of data visualization called Nightingale, where they really have a lot of articles that are quick, short, quite accessible reads about visualization, which is a pretty fantastic resource. In case you're curious about what my own group does, we have lots of stuff. All our papers and videos and software and a bunch of talks, in addition to courses like this one that you're in, are all linked to from that page from my group. And with that, what I want to say is farewell to all of you. It's been an interesting ride this term. I hope you all stay safe and healthy as much as possible. And maybe a fun thing to do for those of you who are interested would be to actually turn on your video if you all want to say a quick hello and wave to each other, because you haven't all been together in the same room for many, many weeks now. So if you would like to, feel free to turn your cameras on at this point. I'm going to stop sharing my screen to make that more visible to you guys. I'm going to also move that off the recording. So if you all want to wave to each other, feel free. And if not, then no pressure. And I am going to stop the recording now, but I'll leave the Zoom live stream going just for a few minutes more. Thanks to you all for participating in this pilot version of visualization. Stay safe and bye-bye. And clapping. Thank you for clapping. I will be doing my office hours after this. I think I can indeed make it through.